Pluto, yeah, it used to be part of the solar system family, but now it's just a dinky dwarf planet way out there. It's kind of faded from attention. Until now, some space experts like Neil deGrasse Tyson and Michio Kaku are saying Pluto might be on a risky path. They think this little icy thing could actually be headed straight for Neptune. This isn't just a wild guess either. They're really raising the alarm. Apparently, Pluto might smash into Neptune. How's that even possible? What would happen if they crashed? Are we being fooled by some space trick? Or is something scary really going on? Pluto gets pretty close to Neptune in its orbit. Tyson and Kaku are seriously warning us that even a small change in Pluto's path could cause a disaster. Could Earth be in danger too? And how could this even happen? Let's break down what a Pluto-Neptune crash could mean. Even though Pluto isn't officially a planet anymore, people are still interested in it. Now that scientists are saying it's dangerously close to Neptune's orbit, that interest has turned into worry. Tyson and Kaku, who everyone knows in astrophysics, are flagging this as a real space problem. They're saying this close pass might not be so safe and could even threaten Earth. But how would it all go down? Pluto's orbit around the Sun is weird. It takes Pluto 248 Earth years to orbit the Sun. Since we found it in 1930, it hasn't made one full trip yet. Plus, its path is strange. It's not round like the other planets. It's stretched out and tilted. Pluto's orbit is tilted 17 degrees compared to the other planets. For about 20 years each orbit, Pluto is actually closer to the Sun than Neptune. Even though it's farther out, it dips inside Neptune's orbit for decades. So why haven't they hit each other yet? It's because of a delicate gravitational dance in the solar system. When we first found Pluto, astronomers tried to figure out its movement. Most planets stick to a flat plane, but Pluto does its own thing. It's got a tilt and an odd path that crosses Neptune's. Still no crash. That's where cosmic mechanics come into play. There's this three-body problem where scientists try to figure out how Pluto, Neptune, and the Sun pull on each other with gravity. It's like a complicated dance where everyone's pulling in different directions. For Pluto, this includes some weird ideas like asynchronous oscillation, orbital drift, and the VZK wobble. These explain why Pluto hasn't crashed into Neptune. Asynchronous oscillation means Pluto is always at least 90 degrees away from Neptune when it crosses Neptune's path. They're always on opposite sides of the circle, which keeps them apart. Orbital drift means Pluto moves up and down compared to the other planets. Even when it's close, it's usually above or below Neptune's orbit, avoiding a crash. The VZK wobble, named after Zell, Kai, and Kaku, looks at how Pluto, Neptune, and the Sun pull on each other. These pulls create a rhythm, a balance that keeps Pluto steady, even though it looks weird. The wobble shows that even though space looks wild, there's order. These patterns keep Pluto on track, prevent a crash, and keep the solar system in balance. This interaction is key to understanding how orbits work and how they shift. It also helps scientists understand other star systems, not just Pluto. Back in the 80s, scientists ran computer tests and found something cool. Even though Pluto's orbit is pretty safe, it can become unstable over time. Small changes to Pluto's position could change its path in the future. But even with that, Pluto's orbit has been pretty stable for a long time. It's like a tightrope walker, shaky but staying up. Modern tools help astronomers measure how Neptune, Jupiter, and Saturn affect Pluto's orbit. Interestingly, Pluto and Neptune have an orbital connection. For every 2 Pluto orbits, Neptune makes 3. This 2-to-3 ratio helps keep Pluto safe. But Neptune isn't alone. Jupiter's strong gravity helps keep Pluto safe. Saturn helps too. Jupiter's so big that it can keep Pluto stable for a long time. Together, these giants act like guardians, keeping Pluto in its place. These odd patterns keep our solar system from turning into a mess. Without them, space would be full of crashes. Pluto is a good example of how knowing about motion in space helps us avoid disasters. Watching Pluto move helps us understand the solar system and its changes. Pluto's weird orbit shows us that even unstable paths can find balance because of gravity. Also, watching unusual objects is important because they teach us about the universe. Looking at space reminds us how weird and cool things are. Pluto's orbit proves it. Scientists call this orbital chaos. It means a planet's path can change based on where it starts and how fast it goes. For Pluto, small changes can mean different futures. That's where computers help. Scientists can test what happens if they change Pluto's position a little. These tests show that even with stabilizers, Pluto can still go off course if it starts differently. But even being unpredictable, Pluto has been consistent for billions of years. That means it's locked into a bigger pattern. It's hard to guess where Pluto will go since these systems are sensitive to small changes. Even good math models have limits because they need perfect starting info. Despite that, Pluto teaches us lessons. The solar system is changing, and our understanding is growing. Even planets we know can surprise us. So why are Tyson and Kaku warning us? Aren't there enough safeguards? Neil deGrasse Tyson played a part in making Pluto a dwarf planet. He didn't do it to be mean but to show how we understand planets better. For him, Pluto shows how science grows. Tyson says Pluto's weird orbit reminds us that we don't know everything, which keeps things interesting. But the idea of Pluto crashing into Neptune worries him. He knows Pluto's orbit has been safe, but small changes could cause a disaster. The paths of Pluto and Neptune make a pattern that could lose balance. Tyson thinks even a tiny push or gravity change could mess up Pluto's path. If those changes add up, it could cause chaos, maybe a collision. This wouldn't happen soon, but Tyson thinks we should watch Pluto's path. He thinks it needs to be studied. Michio Kaku also sees potential danger in space. He likes the beauty of the universe but warns that planetary paths can change easily. Both agree that we should explore space and track the forces shaping our solar system. Pluto's situation shows us how space is always. Discoveries lead to more questions. The chance of a Pluto-Neptune crash reminds us that the universe is hard to predict. Even quiet corners can hold surprises. Pluto's story tells us to stay curious, watch the skies, and remember that the cosmos has mysteries waiting to be found. Now, imagine the impossible happens. Pluto, despite the safety measures, goes off track. Maybe an asteroid bumps it, or a distant object pulls on it little by little. What if Pluto left its safe orbit and started heading toward Neptune? It wouldn't be instant. These things happen over thousands of years. But the results would be big. First, astronomers would notice changes by Pluto arriving at certain points sooner or later. Those changes would add up and one day it could be on a path to crash. Asynchronous oscillation means that when Pluto crosses Neptune's path, they're always at least 90 degrees apart, like on sides of a circle. This keeps them from hitting each other. Then, there's orbital drift, where Pluto's path moves up and down compared to the paths of the other planets. So when it's close to Neptune, it's usually above or below its orbit, avoiding disaster. Lastly, the VZK wobble, named after researchers Zelkai and Kaku, looks at how Pluto, Neptune, and the Sun tug on each other. These gravitational pulls create a rhythm, a balance that keeps Pluto's path steady, even if it looks shaky. This wobble shows that there's still order in space. These cosmic patterns keep Pluto on track, stop it from crashing into Neptune, and keep the solar system in order. This interaction is important for understanding how orbits work and how they change with big bodies like Neptune and Jupiter. It helps scientists understand Pluto and how orbits might act in other star systems. Back in the late 1980s, scientists ran computer tests and found something cool. Even though Pluto's orbit is somewhat stable, it's still shaky long-term. Small changes in Pluto's position or speed could cause changes in where it ends up in the future. But even with this, Pluto's orbit has been balanced for billions of years. Think of a tightrope walker, fragile, but still upright. Modern tools have helped astronomers measure how planets like Neptune, Jupiter, and Saturn affect Pluto's orbit. Pluto and Neptune have a natural partnership. For every 2 laps Pluto makes around the Sun, Neptune makes 3. This 2-to-3 ratio keeps Pluto safe. But Neptune isn't alone. Jupiter's gravity also helps keep Pluto safe, and Saturn adds to it. Jupiter's mass is so big that it can keep Pluto stable for a long time. Together, these 3 act as guardians of Pluto. These patterns keep the solar system from turning into a mess. Without them, space would be full of crashes. Pluto shows how understanding motion in space helps us avoid trouble. Watching Pluto move helps us understand the bigger system and how it changes. Pluto's weird orbit shows us that even a path that looks unstable can find balance with gravity and motion. It also shows why keeping an eye on strange objects is so important. They can teach us how the universe works. Studying the far reaches of space reminds us how strange and cool the universe is. Scientists call this orbital chaos, where a planet's path can change a lot based on its starting point and speed. For Pluto, even small changes to its start can mean different outcomes. Computers help scientists test what would happen if they changed Pluto's position or speed a bit. These tests have shown that even though Pluto has some stability, it can still go off course if it starts out different. Still, it has stayed consistent for billions of years, which means that it is locked into a larger rhythm. Trying to guess where Pluto will go far into the future is hard because these systems are sensitive to small changes. Even the best models have limits because they depend on perfect starting numbers. A small mistake or surprise can mess things up. But Pluto offers lessons. The solar system is always changing, and the planets can still surprise us. So why are Tyson and Kaku warning us about a possible crash? Isn't it safe enough? Neil deGrasse Tyson actually helped change Pluto's status from planet to dwarf planet. He didn't do it to be mean, but so we can understand what a planet really is. For him, Pluto shows how science grows. Tyson thinks Pluto's orbit reminds us of how much we don't know, which keeps astronomy exciting. But he's worried about Pluto crashing into Neptune. He knows Pluto's orbit has been safe, but small changes could add up and cause problems. The overlapping paths of Pluto and Neptune could eventually lose balance. Tyson thinks that even a tiny nudge from another object or a change in gravity could send Pluto off course. If those changes add up, it could cause total chaos. This wouldn't happen soon, but Tyson thinks we should still watch Pluto's path. Miyoku, another physicist, also sees the danger. He and Tyson think we need to explore space and track the forces that shape our solar system. Pluto's situation shows how space is always moving. Every discovery leads to more questions. The small chance of a Pluto-Neptune crash reminds us that the universe is never predictable. Even the quietest spots can hold surprises. Pluto's story tells us to stay curious, keep watching the skies, and remember that there are many mysteries in the cosmos. Now, imagine that the impossible happens. Pluto, after all these safety nets, goes off track. Maybe an asteroid bumps it, or the pull of another object adds up over time. What if Pluto leaves its balanced orbit and starts drifting toward Neptune? It wouldn't be instant, but it could be a huge deal. At first, astronomers would notice small changes. Pluto arriving at certain points earlier or later. Over decades, those changes would add up, and one day it could be on a direct path. When two big things like Pluto and Neptune hit, it changes the solar system. Pluto might be small, but crashing into Neptune would be like a pebble hitting a bowling ball. Except that pebble is made of rock and ice, moving fast. The impact would break Pluto apart, sending debris everywhere. Some of it might get pulled into Neptune's atmosphere, while other pieces could become new moons or drift as space junk.